to another problem session. So this is now, we're up to question 14 in paper 2. Okay, so let's read this. This is actually a very standard problem, but can be confusing because of this little prism over here, a slide over here. So we'll have to blow it up to actually look at what's going on. All right, so let's blow it up. Let's look at the slide. Like this, right? So here's the first slit, here's the second slit. We would try to simplify a little bit that this ray has to go through this much in this medium and this much in the second medium. And this ray, so this slit 1 and slit 2, this has to go this much in this medium and has to go this much in the other medium. So you'll see that this must equal to that just from the geometry, and this is equal to that. So we just have to figure out one of them. So if you look at this large triangle, this is T, and this side is the D, and this L and L. So this is D plus 2L. And if you call this X1, first medium, then X1 over, so versus this triangle, they're similar triangle, X1 over L, this over that, so equal to this over this big thing, D over D plus 2L. So and so the X1 will be just like that, and let's call this X2. Well, X2 will be, I mean, you can do it, subtract it, or you can just look at X. You can look at this triangle versus the big triangle, and so X2 will be, big triangle has, this is X2, and so this will be L plus D, so T times L plus D over D plus 2L. Okay, so if you look at, suppose it wasn't there, then some point Y like that. So this is the, forget about that being there. So if you look at the path difference, delta will be just, so this angle from here, it ends up the same as over here. So delta, and I'm not going to do the derivation because you can drive it. So this difference in the path between this and this direction is d sine theta, and you can call that tan theta, and then you can replace that by y over big D. Okay, so delta between, so what's going on is you you're going to have that path difference in medium with n equals to 1. So it's all about optical path difference, right, in Young's double slit. So we want to know optical path difference between things originating here and things originating here, between ray 1 and ray 2, or wave 1 and wave 2, whatever view you want to take. Okay, so if you look at here, it's going to go in let's call it this medium 1, medium 2. So in addition to the delta, there will be n1 start working. So let me try again. Let's take this red pen. This is supposed to be black pen. Let's take this red pen one more time, refreshing it. Yeah, so n1 in x1 for this ray plus into x2. So this additional path that I need to include for ray 1, and I need to subtract ray 2 from it, and for that you'll have n1 x2 plus n2 x1. For this other ray, it's just going to flip, because this x2 and this part becomes x1. And this is refractive index is 1. So this is the OPL, optical path length difference in the two directions. And the condition of constructive interference will be if this equal to n times this, the order, let's call it m, and m can be 0, plus minus 1, plus minus 2, etc., then constructive interference. Okay, so of course m equal to 0 is the central, and so when this is not there, so this is, if you look at this delta dy, so let's write that y d over capital D. So when this part is, so m is equal to 0 for us, so when this part is not there, you can see that y will be at 0 when m is 0. And the question is, when m is 0, where would the y be? Okay, so we have y d over d. This kind of simplifies if you look at n1 and n1. So n1, and we are going to just look all the positive, just for the positive part. So we have n1 x1 minus x2, and if you take a plus n2 x2 minus x1, x2 minus x1. So if we can write this guy also x2 minus x1 by bringing minus here, then x2 minus x1. And if you take x2 minus x1 common, then it's going to be plus x2 minus x1 n2 minus n1 equal to 0. So if you want plus or minus here, just to make it absolute value, doesn't matter. So y will be d over d. We're just looking at the positive part. d over d times delta x delta n so but the way we have written it down here, if you want to carry the sign, that's okay. So this will go into minus if I call this delta x, and it's called this delta n. Let's see, d is now time to put the numerical value. D is 2 meters. Got to be careful. The answer is supposed to be in millimeters, so I'm going to write everything in millimeter, especially so 2 is equal to, you have a minus 2 times 10 to the power 3 millimeter, and maybe everything else I can write same unit here and no unit here, and this is 0.2. Actually for us n2, this minus 0.2. Maybe the nib is getting short, so this minus, and so this, let's capture these minuses together. So 2 times 10 to the power 3 millimeter times 0.2 for this guy, delta x. D is in, so let's see what the delta x was. So x is this, x2, so delta x we've written is x2 minus x1. So you have this TL will subtract out, so you get TD over D plus 2L. So let's start over again. Y equals to minus D over D n2 minus n1 TD over D plus 2L. Of course, D is cancelled out, so I don't use it. So these will be put in the same units. So minus 2 times 10 to the 3 millimeter times minus 0.2 times thickness. Let's see, thickness was 12 micrometers. So let's call it in millimeter, 0.12 millimeter, 0.012 millimeter. So decimal is right there. And D is 2 millimeter and L is 1 millimeter. Okay, so this is 0.4. So 10 to the 3, let's absorb this and make this guy 12. And this will become 4, makes this 3, 1.2 millimeter. Okay, so that's how far it will shift. In this diagram, the way the n values are is going to shift over here. 1.2 millimeter. If you flip the plates backward, it's going to flip downward, because then delta n will become negative here. So depending on how you put the plates, is going to shift up or shift down. Okay, so it says the way it's actually given the data, in that data is going to be 1.2 millimeter. Okay, that's that was a pretty decent problem. I enjoyed doing it. I hope there are more problems like that in the remaining part of the test. All right, see you in the next question. Bye.